In this video, let us see about conformal mapping. First, the definition is the mapping or transformation function W is equal to f of z under which angles between every pair of curves through a point are preserved in both magnitude and direction. So, such transformation is called as conformal mapping or conformal transformation. So here, if you consider a curve represented in both z plane as well as w plane under the transformation w is equal to f of z, it should be preserved in both magnitude as well as direction. Then we can say that the mapping is the conformal mapping. Whereas if it is preserved in magnitude alone but not in direction means then we can say that the mapping is an isogonal mapping. Okay, so this is the difference between conformal mapping and isogonal mapping. While coming to this conformal mapping, we are having four types. First is magnification, second magnification and rotation, third inversion and reflection, and fourth is translation. So magnification means here magnification alone occurs here. So the transformation should be W is equal to AZ and A being a real constant. So here the image in the W plane will be magnified 8 times. That is the meaning. Next, type 2 is magnification and rotation. So here A should be a complex constant. So what happened here is the diagram will be magnified 8 times as well as meantime rotation also takes place. And inversion and reflection. Inversion and reflection means if the transformation is W is equal to 1 by Z, then it is called as inversion and reflection. Next, translation is W is equal to Z plus C, where C being a complex constant, translation occurs. Which means that here, translation means the image will be shifted to a distance of modulus of C. Right? So, these are the four types of transformation. Now, let us see problem based on this mapping. So, now let us see the first question. Find the image of the rectangular region in the z-plane bounded by the lines x equal to 0, y equal to 0, x equal to 2 and y is equal to 1 under the transformation w is equal to 1 plus 2iz plus 1 plus I. So here it is of the form w is equal to az plus c, and A being complex constant and C is also complex constant. So based on the various types we have already seen, here A being a complex constant, here magnification occurs, rotation occurs. And because of plus C, translation also takes place. So what happened here is the image in the Z plane, image in the W plane will be magnified and rotation takes place and also it will be shifted to a certain distance, that is modulus of C. So now let us see here what happens. First we have to consider the values, that is here the diagram in the Z plane is nothing but is a rectangular region. Rectangular region means x equal to 0, y is equal to 0, x equal to 2 and y is equal to 1. So first let us form a rectangle in a Z plane. So based on that we have to consider the transformation. So here first let us consider W is equal to, it is given 1 plus 2i into Z plus 1 plus I. So first let me write it as in terms of u plus iv. So here 1 plus 2i into Z should be replaced as x plus y into 1 plus I plus 1 plus I. So now we have to multiply this. While multiplying this and splitting it into real and imaginary part, what we will get here is x minus 2y plus 1 will become the real part of this term plus I into imaginary part will be y plus 2x plus 1. Clear? So this is W, which means that u is considered as x minus 2y plus 1 and then v is y plus 2x plus 1. So now considering this u and v, we can take the coordinate points from the rectangular region mentioned here in the z plane. We have to first identify the coordinate planes of x and y. So while substituting these coordinate points x and y, we can obtain the corresponding coordinate points of u and v, which will be represented in the w plane. Okay, so now first let us form a rectangular region in the z plane. So this is a rectangular region mentioned in the z plane. So this is taken as x-axis and y-axis, and the coordinate points are 0, 0, and this is 2, 0, and this is what is this, 2, 1, and then this is 0, 1. Clear? So now what happened here is this is the rectangular region in the z plane. So now we have to consider these coordinate points for x, y, and corresponding to this x and y, we have to identify the coordinate points in the w plane. So here let us consider the coordinate points for the z plane and the coordinate points in the w plane. So this is for xy and this is for uv. So what are the coordinate points in x, y are 0, 0 and 0, 1 and 2, 0 and then 2, 1. So now corresponding to this, here you know what is u and v. So we have to substitute this 0, 0 here in u and v. So here u gives you 1, again here v is also 1. So u, v is 1, 1 corresponding to the value 0, 0. Similarly 0, 1. 0, 1 if we substitute in u and v, we will be getting the point as minus 1, 2. Similarly for 2, 0, we will get 3, 5. And similarly for 2, 1, we will get 1, 6. So these are the points which should be plotted in the W plane according to U and V. So this will be the image of the Z plane. Right. So now we have to plot it in the graph. Now this is the diagram represented in the W plane, where this represents the axis U and this represents the axis V, and this is the point 1, 1, and this is the point minus 1, 2, and this is 3, 5, and this is 1, 6. 1, 6. So now if we notice, this is a rectangular region represented in the Z plane. So based on the given transformation, it has been transformed into a diagram like this. So this is the image of that rectangular region in the W plane. So where if we notice, the here magnification takes place, rotation and also translation. Okay, so this is an example for the conformal mapping for the given transformation. W is equal to 1 plus 2i into z plus 1 plus I. Now let us move on to the next question. Find the image of the infinite strips 0 less than y less than 1 by 2 under the transformation W is equal to 1 by z. So if you look at the transformation here, it is inversion transformation, that is W is equal to 1 by z. So for that, before moving to the diagram, first we have to consider W is equal to 1 by z. This is also equivalent to z equal to 1 by w. So first let us consider to be z as 1 by w, which is equal to 1 by u plus iv, because w is equal to u plus iv. Now we have to multiply and divide by its conjugate, that is u minus iv. So while multiplying, dividing by its conjugate, numerator becomes u minus iv divided by denominator u plus iv into u minus iv can be written as u square plus v square. After writing like this, now we can split it into real part minus I into imaginary part is u square plus v square. So like this we can write. So which means that here z is nothing but x plus iy. So z is considered as x plus iy. Now if we equate real and imaginary part on both sides, So x is considered as u by u square plus v square, and y is the imaginary part here. So minus v divided by u square plus v square. So after writing x and y like this, now what is the question given here is infinite step 0 less than y less than 1 by 2. So here we can consider, or we can split this inequality as y greater than 0 and y less than 1 by 2. So while writing like this, now y greater than 0 means this is y here. So we can write minus v by u square plus v square is greater than 0. So while writing like this, cross multiplying this, we will get minus v greater than 0. If minus v greater than 0, then v should be less than or equal to 0. So this is one inequality. Similarly, we have to do it for y less than 1 by 2. For y less than 1 by 2, here again minus v by u square plus v square is less than by 2. So now we can cross multiply this. While cross multiplying, we can write minus 2v less than u square plus v square. Now we can take it to one side altogether. So we can write u square plus v square. This minus 2v will go here as plus 2v, which will be greater than 0. So both are same. The previous equation can also be written like this. Now to make this term as a perfect square, we have to add and subtract certain value. So here to make it as a perfect square, we can add plus 1 and minus 1. Add and subtract 1 here, so that u square plus v square plus 2v plus 1 and minus 1. That minus 1 can be taken to the right side again as plus 1. Or otherwise we can add plus 1 on both the sides. So now what happened here is this can be written as a perfect square as v plus 1 the whole square greater than 1. Now this is the equation of the circle with center 0 comma minus 1 and radius is 1, because this 1 can be written as 1 square. And then moreover, this greater than symbol represents the exterior portion of the circle. We have to consider the exterior region, okay, because of this greater than symbol. If it is less than means we have to consider interior region. This is the diagrammatic representation in Z plane and W plane. So this is the infinite strip represented by the inequality 0 less than y less than 1 by 2, which means that this is the line y is equal to 0 and this is the line y is equal to 1 by 2, and the region in between these two lines are considered as infinite strip, because equation y should be greater than 0 and y should be less than 1 by 2. So now the image to this infinite strip is nothing but the region represented in the W plane like this. Here we have identified two equations. One is v less than or equal to 0. Another is the circle with center 0 comma minus 1 and radius is 1, and moreover it should be the exterior portion, exterior part of that circle. So now let us consider this is to be the circle with the center 0 comma minus 1 and radius 1, and then exterior portion. Exterior portion means this is the exterior portion you have to consider, and then v less than or equal to 0. What do you mean by v less than or equal to 0? Means this is the line v is equal to 0. U axis is nothing but v is equal to 0. The region below this u axis is considered as v less than or equal to 0. So that is, and moreover exterior part means we should not shade the region inside the circle. The region should be exterior outside the circle. So this region is an unbounded region, and this is the image of the infinite strip represented in the Z plane. And this is the conformal mapping. Using conformal mapping for the transformation W is equal to 1 by Z, the infinite strip has been transformed into a unbounded region like this in the W.